Hey guys, welcome to this video. So in this video, we're going to be covering texturing and material basics. And what we're going to be trying to do is build an understanding of the differences in texture and material qualities and kind of how all this works with regards to textures, materials, and 3D models that these things are going to be applied to. So let's do a quick UV and textures review. Again, a texture map is a 2D image created to fit onto a 3D model. So here we have this wireframe of a 3D model, the Corrupted Iron Knight. We saw him earlier. Here we have the texture map. It is a 2048 pixel by 2048 pixel texture map that is going to wrap around that UV'd model, and then this is what it ends up looking like, right? Here we have a couple of other examples. Again, here we have a character, and you can see the actual flat painted texture that is wrapped around different parts of the character based on how the UVs of the character have been laid out. And here again, we have an example of a weapon, a sword here, that has been hand painted and textured. Again, you can see the 2D texture at the top and the textured version of the sword underneath it. This is actually particularly important because you guys are going to have the opportunity to do something similar for this activity. So let's talk a little bit about material basics. Materials in 3D are what are going to give an object its surface and subsurface qualities. And subsurface qualities mean things that are directly under the surface. As an example, if you guys have ever looked at a wax candle, sometimes it looks like it's almost a little see-through. For example, if you've ever taken a flashlight and put it on your hand and then looked through your hand a bit, you'll notice that you can kind of see through your hand a little bit because the way our skin and our body works, actually light goes into it, goes under the surface or subsurface, scatters, and comes back out. So when we're trying to make skin in 3D look right, you actually have to do that. A material type and its attributes determine how light interacts with an object. So it's not only the textures that are on a material, but material types act specifically in certain ways with light or interact with light in specific ways, and that will change the resulting look. Software packages and renderers use different calculations in this regard. So you have different renderers, like Maya has a default software renderer, but you also have something like RenderMan, which is the one that Pixar uses. You have iRay, which comes in Substance, and then you have Maya's real-time renderer, the hardware renderer, or Viewport 2.0 is what it's called. You have renderers that exist within game engines like Unreal or Unity. So it's important to note that the shaders work with those renderers to get the results you want. And in fact, here we have an example of how a layered material shader in RenderMan will work a little bit. This is kind of a very brief breakdown of how the different layers in that material interact with the light going through it. And here we actually have examples of how that would work in a physical-based render, or PBR, which is also something that's very important. But for now, guys, I don't want you to freak out too much about this because really all that matters is the final results, which is making pretty art, right? So if this is something that you end up wanting to make a career out of, it can get very deep, and it can be very lucrative, by the way. But for right now, I don't want you freaking out about this too much. I'm just showing this to you to give you guys an introduction, essentially. So let's talk about the default materials in Maya, actually, Maya's software materials. And right now we're going to talk about three specific ones, the Lambert, a Bling, and a Phong. Now there are more, but these are the three that we're going to be talking about right now. And you can actually see the materials laid out here in Maya's Hypershade and the attributes for all of this materials laid out. Now, I don't want you freaking out about everything you're seeing in that window right now, okay? The main things that I want you to focus on are that color one at the top. That's the only one you guys are going to have to worry about. Now, these are old school materials. They're not really used as much in the pipeline right now, but they're a great starting point. And again, like I said earlier, if you can make good looking art with it, it doesn't really matter what you used initially. Like I was saying before, we're only going to be focused on the color channel of a Lambert right now. But as an example of the difference in these materials, Lamberts reflect light a certain way. They actually reflect light more diffused. So it's similar to almost how like cloth would reflect light, or just something that isn't very reflective. While as blends and Phongs tend to reflect light in a more reflective way. And it has to do with their surface qualities. Again, I don't want to get into this too much, but these are kind of how these materials are built. Now, RenderMan materials, you will notice here, this is in Maya as well, actually, and this is a Pixar surface material. There are more to work within, and you'll notice that some of the attributes in here are different because this material calculates differently than Maya software materials do. In fact, Maya software lighting will calculate with the materials differently than RenderMan lighting. So all of this stuff works in tandem, and it's important to know what system you're working within. RenderMan is actually currently used by Pixar. It's one of the more commonly used renders in film and other pre-rendered media, so commercials, TV, all that kind of stuff. You guys are going to be using it here, so it's definitely something to start getting to know. Now, PBR materials. This is a little different. PBR materials kind of look like this, right? This is a little bit different, you'll notice. They are still node-based depending on where you're working within them. But they have different criteria. So their color, instead of just being a regular color, is a base color. But then you also have you actually have different workflows where you have a metal workflow and a specular workflow. You'll get slightly different results with them. But the important thing to note is that PBR materials involve physical-based rendering, and they're accurate simulations of photorealism. They're actually using real-world scientific information to figure out that gold is this specific number here with regards to how it reflects and with regards to the color that it is, its metalness, its roughness, etc. While as glass will be this and wood will be this. So it's pretty scientific. It's the predominant method used for texturing in real-time applications, but it is also used in other facets of the industry. It's very dynamic. It's really it's coming on very strong over the last, I would say few years, but it's been probably like a good 6-7 years now that it's been used more and more. And I would almost venture to say that if you go into video games, you cannot work in it without having at least some understanding of the PBR material workflow. I want to talk about now PBR in combination with Substance. So Substance is a software package that you might use, and there are some benefits to working within PBR and within Substance specifically. And this is actually from Substance's own words for the most part. There's no guesswork with PBR. So the methodology and algorithms are all based on physically accurate formulas. The nice thing about it is that your assets will look accurate in all lighting conditions because it's all based off of a universal scenario. So like I was talking about before, Maya software is going to work differently than RenderMan. That'll work differently than an under-renderer. And I will say this, PBR doesn't necessarily play well with those renderers. But if you're working within a PBR workflow, generally, if you move from one PBR renderer to another, your materials and textures will stay consistent. And this is really nice because if you pass work from one artist to another artist, it doesn't come down to this artist thinks gold looks like this, and this artist thinks gold looks like this, or this artist thinks wood should look like mahogany, should look one way while one thinks another. It is actually brought down to a specific science. The other great part about it is it's procedural and non-destructive tools, but they combine with an artist eye. So we talked a little bit about the difference between hand painting and procedural, and Substance gives you this nice sort of middle ground, and it's why it's so incredibly powerful. I would suggest, not right now, but as you're moving forward, if you become very interested in Substance, visit the Substance Academy because they just have probably one of the best collections of tutorials and information on PBR and Substance. And it's out there for free for everybody. They want you to use it. They love for people to have it. So go get it. So we're going to talk about two facets of Substance workflow right now. I'm going to talk about Substance Designer, and then I'm going to talk about Substance Painter. So Substance Designer allows for the creation of new procedural materials. Generally, they're tileable. These materials are made up of multiple texture maps, so they kind of look like that right there. You can see that you have that concrete material on the left above, and then the way the texture maps for it break down, each of those bars that you're seeing in those images on the right are part of the different material breakdowns. So the ones that you see in there that are a little bit purple and blue, that's actually what we call a normal map. And a normal map fakes like relief information. So if you want to make something feel like it's cracked or like it's got a lot of bumps or like the grass is all bumpy, but you don't want to have to make geometry for that, you can actually use normal maps. Now, a lot of those other maps are going to work on different things like color, diffuse, albedo, metalness, roughness, etc. But I just wanted to show you kind of how they work together. And here you're actually going to see this is actually from the Substance magazine or Algorithmic magazine. And this is actually a workflow used in the latest Gears of War to help create this rock material that was going to exist in different areas of the world in this red sand world, right? So you can actually see the rock material on the right, and on the left you can see a little video of that rock material being built up and blended into the environment. And this is why it's so great, because it allows for this sort of dynamic interaction of texture maps as well. Now, once you design your materials in Substance Designer, you can use them in Substance Painter. Painter allows you to mask and combine materials on a 3D model, and it'll allow you to paint on the model in a 3D viewport. And in doing so, you can create a lot of really cool stuff. For example, here, I think this is from Clash of Clans. So this is one of the characters in there, and they use a Substance workflow. Here we have an example of a missile pod armory thing from, I believe it's the Division 2. And they actually talk about a customized workflow that they started creating within Substance Painter. Now, it's very important to note, guys, that no matter how powerful the tools are, we're going to need reference. The best of artists, no matter what the tool can do for you, still has to go out and figure out what is it that they're trying to recreate, right? So as an example here, we actually have characters from Apex Legends. And right here, you can see concept of the character, but you can also see this is a material worksheet breakdown where the artist went out and gathered photographic reference of different materials in the real world and basically said, all right, I know that I want these different parts of the character to look like these materials. So they set this up so that eventually they could go into Substance, recreate those materials as accurately as possible, and then use those different material sets that they've created within the game to then create multiple more sets of materials. Because Substance is procedurally based and non-destructive, once you create a base material, it can become very easy to create iterations of that material because you don't have to hand recreate every part of it. But again, guys, let me emphasize, you always need reference. No matter what you're working on, get reference of stuff that's out there so that you're trying to accurately mimic something and you know what your goal is. So let's talk about hand painting textures, which is one of the things that you guys are going to be doing in this activity. Hand painted textures lead to a unique result. We've talked about this before, and it can be more painterly, but that can take a lot of time. Now, if you happen to be really smart at problem solving, you can actually use procedural workflows to create results that look hand painted. So this example that I'm showing you right here is actually by an artist at Blizzard. His whole tutorial is on his ArtStation right here, Louis Armstrong. So you can just go to his ArtStation and see how he actually put this together. But that is a procedurally based material. It is not just him hand painting that. He also used ZBrush to build up some of the initial mesh and the model. But I wanted to point out that even though that looks hand painted, he didn't actually paint that by hand. He's using a Substance workflow to generate that. Same thing here. This is actually off of Substance's website. And as you can see on the top, it's kind of swapping between all of the different texture maps that make up the finalized materials for this environment. And then in the bottom, you can see what the final render looks like once all of these materials have kind of been mushed together. And this project was done specifically to create an environment that has an almost hand-painted anime style look. So they're, again, using Substance materials and Substance workflow to create hand-painted results. I'm telling you about this, guys, because beyond the fact that I just think this stuff is really cool, when you guys move into studio environments, you do really want to be problem solvers. If you guys can come up with kind of an interesting new way of doing something, or even for yourselves, figure out a quicker, more effective way of doing something, that's one of the most important parts of being a professional artist, whether it's 2D, 3D, any kind of artist. So I would challenge you to start looking at that kind of stuff. Now, for this activity, you guys are going to be creating hand-painted textures for models of your choice. Now, you're not going to be using Substance or anything. Like I said, a lot of stuff I talked about was just intro. You guys are just going to be using Photoshop for the hand painting part, and then Maya for the models. Now, we are going to provide models for you. Here are the models that you guys actually get to pick from. And then what you're going to be doing is you're going to be taking a model that you have chosen, right? So here we have this axe model, and you guys are going to be painting textures in a Photoshop file that we've given you as well that are going to then wrap around the 3D model. And you guys are going to be completing all of that and submitting all of that to us for review in this activity. So, guys, I hope having gone through these slides, you guys have a better idea of kind of how different aspects of the texturing and material process work. And you have a good idea of what we might be doing in this activity a little bit later. So keep on pushing forward, guys, and I look forward to working with you in the rest of this activity.